Most engineers design for success. Senior engineers design for containment. There is a difference. So, success paths all assume everything works, and containment assumes something breaks. And when it breaks, how far does the damage spread? That is called the blast radius. So, blast radius is simple. If this fails, how big is the impact? So the impact can be on one feature, one service, one region, or the entire platform. That single question separate architecture from diagrams. Let me give you a real example. Suppose imagine we are having an AWS architecture, and that architecture includes API gateway, Lambda functions, RDS database, and S3 storage. So it looks clean, but authentication is handled by one shared Lambda authorizer used by all services. So if that lambda fails or its IAM role is misconfigured, everything stops. Like login fails, fail, background job fail, and the diagram stays still says serverless and scalable. So reality says a single point of collapse, blast radius is equal to entire platform. Now imagine the same system with isolated authentication microservices, circuit breakers, graceful degradation for read-only paths, or token caching fallback. Now its auth slows down. User can still browse. Cart may still load. Only sensitive operations pause. So blast radius is reduced, and that's called architecture thinking. In Azure, I have seen similar patterns like single shared Azure key vault used by web apps, used by functions, AWS workloads, data pipelines. So when key vault throttles under high load, suddenly what happens? Like what impact it can give? So it can be like a pods fail to retrieve secrets, functions failed cold starts, deployments break. So the issue was not scaling. The issue was shared dependency concentrations. So blast radius mistake. Now senior engineers map blast radius before implementation. They ask, if this dependency fails, so what can happen? Does traffic reroute, or does it degrade, or does everything crashes? If the answer is everything crashes, the design is not production ready, even if it worked perfectly today. Here's another scenario. That scenario is related to Kubernetes cluster. All workloads in one node group, and we are having a shared security group, shared autoscaler. Now there is a misconfigured update that drains node incorrectly. All workloads evicted. There is a full outage. Nothing wrong with Kubernetes or its clusters. So that's an architecture mistake. Blast radius, it is too high over here. It is too large. And that is like containment techniques senior uses. So here we can say multi-AG separation, service level isolations, or resource quotas, rate limiting, circuit breakers, like feature level degradation. Not because they are trendy, because containment limits damage. Production failure are inevitable. Wide failures are optional. If your system fails small, you can recover it fast. If it fails wide, you write postmortems. So, next time when you design anything in AWS or Azure, before asking, how do I scale this? Ask, like, if this breaks, how much burn that answers, like, how much burn? So, that answers define your architecture maturity. Production does not care about your diagram, it cares about containment. When something breaks, and it will, like, and it will, users don't judge uptime percentage, they judge impact. Did one feature glitch, or did the entire platform disappear? So that's the difference between architecture and configuration. Most engineers build systems that that works. So senior engineers build systems that fail safely. And if you remember nothing else from this video, uh, if you remember nothing else from this video, then just remember this. Reliability is not about preventing failures, it's about limiting damage. Next time, when you review a design, don't ask how powerful it is, ask how small it fails. That questions alone will change how you build forever. Thank you.